Please go.
In this video, we're going to talk about using dimensional analysis to solve a problem that has units in both the numerator and the denominator. We're going to convert 75 miles per hour, pretty much a normal speed limit, to the units of meters per second. So to start with, we're given a quantity of 75. Miles are a unit of length, and this word per in word problems means divided by. So we could put that with a big division sign and hours as the unit of the denominator. If you wanted to, you could put 1 with that hours. It doesn't matter because you'd just be multiplying or dividing by 1. So in the process of solving this problem, we're going to have to run through a bunch of conversions to get this unit of length ultimately to meters. And we'll have a series of conversions that help us get from the units of hours to seconds. And it doesn't matter what order we do these conversions in, as long as we're sure that the units cancel every time, getting us closer to meters divided by seconds at the end of this thing. I think most of us are familiar with the time conversion, so we're going to start there. Hopefully you know that 1 hour is equivalent to 60 minutes. And in the context of this problem, now to cancel these units of hours, we would use that equality with 1 hour in the numerator and 60 minutes in the denominator. And the hours would cancel. If we stopped solving this problem right now, we would have 75 divided by 60, and the units on that would be miles per minute. Well, it's not quite the units that we need at the end of this. We have one more time conversion. Hopefully you know that 1 minute is equivalent to 60 seconds. So based on the principles that we talked about in class, using this equality as a conversion factor would force us into placing 1 minute in the numerator and those 60 seconds in the denominator, and our units of minutes would cancel. So that gets the time conversions complete. Now seconds match the units that we need at the end of this thing. So now we have to focus on the length. We're given miles and we have to convert that to meters. We have to go between an English and a metric unit. You're not required to memorize any equalities to help you carry out a conversion like this, but in practicing problems and in doing your homework, if you need an equality, I expect you to be able to look it up. So in your textbook, you can find a relationship that says that 1 mile is equal to 1.609 kilometers. And that's a helpful relationship in solving this problem. It lets us say that 1 mile, and notice that I put the mile in the denominator because back over here in our starting quantity, miles were in the numerator. The 1.609 kilometers would be in the numerator of the conversion factor. And again, that would help our miles to cancel. So we're almost at a solution. If we stopped right now, our units would be kilometers per second. We've got to do one more metric conversion that helps us relate kilometers to meters. And you can look at your exam information sheet and see that the prefix kilo is equal to 10 to the third. So in the context of this problem, we would say that 1 kilometer is equal to 10 to the third meters. And then we're just going to take the pieces of this equality and put them into a conversion factor so that our units cancel. We've got to cancel kilometers. So 1 kilometer will be in the denominator of this, and 10 to the third meters will be the numerator. This allows us to cancel the kilometers and leaves us with meters per second, the unit that we're asked to find in the solution. The units work out okay. Now we have to agonize over the numbers a little bit. In the numerator of everything, we've got 75 times 1 times 1 times 1.609 times 10 to the third. We can make these two times signs the same. And then in the denominator, we've got 60 times 60. And I think if you punch all those numbers into your calculator is going to say something like 33.52. The units on that are meters per second. And the final thing that we always have to do when we solve a problem using dimensional analysis is to round our answer for the correct number of significant figures. We started with a quantity that had 2 significant figures. All of our conversion factors were composed of things that were either exact or that were measured to more significant figures. So knowing that we start with 2 significant figures, we better end with 2 significant figures, and we would round this to 34 meters per second as a final unit and number. So that's dealing with a quantity that has units in the numerator and the denominator. What I'd like you to do right now is carry out another one of these conversions and see if you can get it right on your own. I'm going to ask you to convert 3.68 times 10 to the 5th. And the units on that are going to be milligrams per deciliter to the units of nanograms per microliter. I'll ask you to stop the video, pause it, and then solve the problem. So pause it now, and then we'll go over it. Here we go. We're going to start with 3.68 times 10 to the 5th milligrams per deciliter. I'm not going to put in the 1 in that denominator. We can work through our mass conversions here pretty quickly. We've got to go from milligrams to nanograms. The prefix milli means 10 to the negative third. So 1 milligram is going to be 10 to the negative third grams. We would put the 1 milligram in the denominator and 10 to the negative third grams in the numerator. We have to then convert to nanograms, and the prefix nano means 10 to the negative 9th. So 1 nanogram is equivalent to 10 to the negative 9th grams. In this problem, we would want that 10 to the negative 9th grams to be in the denominator, allowing us to cancel the grams, and 1 nanogram is in the numerator. So these units come out. And now we have to think about this unit of volume, the deciliter. The prefix deci means 10 to the negative 1. So 1 deciliter is going to be equivalent to 10 to the negative 1 liters. And I've got to cancel those deciliters. So when I use this equality, I'm going to put the 1 deciliter on the top and 10 to the negative 1 liters in the denominator. And then finally, to get to microliters, micro means 10 to the negative 6th. So 1 microliter is 10 to the negative 6 liters. In solving this problem, then, the 10 to the negative 6th liters would be in the numerator, and 1 microliter would be in the denominator. Liters come out, deciliters cancel, and the units that are left are nanograms per microliter. And then all you have to do is work through the exponents. in this one. When you're all done, I believe you get 3.68 times 10 to the 6th. Let me just check that. Yep. Nanograms per microliter at the end. And that has the correct number of significant figures based on our starting quantity. All of the conversion factors in this one were exact. They came straight off the exam information sheet and were just applied to the correct base unit based using our conversions. Thanks for watching. We're done.